This instructional video is designed to show you how to calculate binding energy per nucleon by taking advantage of what we understand of how we combine protons and neutrons in order to make different nuclei. And so the first step then in talking about the binding energy is recognizing the reaction we have to write. And so in this case we're talking about forming nuclei. So our carbon-12 becomes the product. And carbon-12 has 6 protons and 6 neutrons. So we are taking 6 protons and 6 neutrons and squeezing them together to form our carbon. In the same way, for our chlorine, we have 17 protons and 20 neutrons. So we will take 17 protons plus 20 neutrons, and this will form our chlorine 37. So step 1 then is writing the reactions. Step 2 requires us to determine the mass defect. The mass defect is the amount of mass lost and converted into energy when we congeal all of those protons and neutrons together to form a nucleus. So for carbon, what we're looking at then is mass of products minus mass of reactants. So 11.996708 units. And we will subtract off 6 times the mass of the proton, 1.0073 units, and the mass of the neutrons, which is 6 times 1.0087 units. So we have products minus reactants. In the same way, we'll do that here. 36.956576 units minus 17 times the mass of the proton and 20 times the mass of the neutron. So when we complete this subtraction, we'll find our mass defects. And so for carbon-12, we have a mass defect of negative 0.099292 units. And for the chlorine-37, we have a mass defect of minus 0.341527 units. So now we know how much mass was lost and converted to energy. And now all we need to do is multiply by a conversion factor. So to convert from atomic mass units to MeV, that's 931.5, and we'll use the same conversion factor here. 1U is 931.5 MeV. And so for carbon-12, that comes out to a release of 92.49 MeV. And for chlorine-37, we have 318.13 MeV. And so if we want to convert this from just the energy change for the reaction to get the mass defect, we've done the subtraction to convert the mass defect into binding energy. We've done the unit conversion. And in order to get binding energy per nucleon, we simply need to recognize that there are 12 nucleons in our carbon. So we would divide this by 12. And because there are 37, we'll divide by 37. And that'll give us the binding energy per nucleon. nucleon. So once you get the binding energy, just divide by the number of nucleons, and that will tell you how to find binding energy per nucleon, given the masses of protons and neutrons, as well as the mass of the parent nucleus.